Hello again everyone, and welcome back to Decode Tech. So we've been talking about object-oriented programming and classes and objects. And this video is going to be an introduction to inheritance. So to get started, we've been working with coffee maker objects. And so if we're going to make a cup of coffee, we're going to have a mug to put the coffee in. So let's start off by making a mug class. So we're going to call it class mug. Remember, the convention in Python is to start a class name with a capital letter. And then you can either have parentheses or no parentheses. I'm going to leave off the parentheses for now, but we will come back to those in just a bit and explain what they're for. And I'm going to put a colon because we're going to need a block of code associated with this class. And whenever we make a mug object, we're going to want to initialize some attributes, or just variables in other words. And so we're going to use the special method called the init function, or init, short for initialize. And once again, these double underscore methods and variables are just something that gets called automatically by Python, and we're just overriding it here. And it's a function, so we need open and close parentheses, and since it's inside a class, we'll use self. Functions also need a block of code, so we'll use a colon once again. And now, what are some things we might need for a mug? Well, how about the size of a mug? We might have a small, medium, and large size mug. So let's make an attribute called self.sizes. And then we'll assign this to be, how about a dictionary? Now let's map sizes like small, medium, and large to integers to indicate how many fluid ounces this cup can hold. So for example, we'll do small colon gets an integer level of, how about 6 fluid ounces, comma. Now remember, that's the key and that's the value. So dictionaries have key value pairs. And if you don't know what that is, you can check out my video on dictionaries. Then we'll do medium size, and we'll say that gets 8 fluid ounces, and we'll say large, and that'll get an integer value of 10. Now, since any one mug instance won't be all 3 sizes, this might be a better candidate for a class variable. So instead of self.sizes, I'm going to cut this, and I'm going to put this up above the init function, but one tab inside the class. And now we'll just give the instance variable self.size, and we only want one size. And so we'll probably want to take this in when the object is created, so we can take in another parameter of size up here. And we want to use the class sizes variable to map if the user puts small in for the size, that it sets the size to be 6. Because we'll see later, we want to be working with the integer value. So what I'm going to do is I'm going to say mug without the parentheses, because that would create an instance of a mug. We want just to access the mug class and the variable called sizes. And now that's a dictionary, so we can use not index notation, but rather the key. So it looks like index notation with the brackets right after sizes, but we'll just use the key name. Instead of hard coding in a size like small, we're going to be getting that size from whoever creates the object. All right, and your cup might also have a color, so we'll do self.color, and for now we'll just hard code it to be green. We might also want to see how full the cup is, so we might say self.howfull. And whenever we initially create a mug object, I'm just going to set it to be 0. And that is why I wanted self.size to be an integer, so we can see if it's full or not. So let's see how we're doing so far, and let's actually write some code from this class blueprint. So let's start off by defining a main function, and let's just not take any parameters, and let's just start to make an object. So let's say m for mug gets our mug object. And remember, we can know it's an object and not a function because of the capital letter in m. Now self gets passed as the instance, so m gets passed in as self, and that happens automatically, but size we do need to specify. So let's just say this is going to be a small mug. And now let's print out m.size. And how about we try to fill up this cup by doing m.howfull. And let's set that equal to 8. And now let's print out how full. So m.howfull. And now if we actually want to run this code, we have to call the main function. But let's do that little thing we learned called double underscore if name equals the string of double underscore main. Of course, it needs a colon, and our main function will be inside that, so it'll actually run our main program. So I'm going to save, go down to the terminal, I'm going to type in Python, and the name of my file, main.py, hit enter, and you see we get 6 and 8 printed to the screen. Now you see a problem with our code in that it's fuller than the size of the cup. So the cup can hold 6 fluid ounces, and we put 8 fluid ounces in it by directly accessing the how full attribute. Now this can be a problem that comes up when you have direct access to a instance variable, and I'm not going to touch too much on that, but that comes into a topic of getters and setters and data hiding. But since we're just going over the basics for now, I'm just going to tell you that basically what this means is you want to write a function to be able to fill up your cup. A function in a class is called a method. So let's go up in our class and let's define another function and let's call it fill. And of course it's going to take self so we can access an instance. And we're just going to say self.howFull and then get whatever it currently is plus whatever a level a user passes in. So we want to see how much they want to fill it up. So we'll pass in level. And so we want to say equals self.howFull plus level. So it'll add the level to whatever's currently in howFull and then store it back in howFull. But we've learned a shortcut for this called incrementing, which looks like this. Self.howFull plus equals level. And then we might want to return how full it currently is. So we'll return self.howFull. Now that won't print to the console unless we print it out when we call the function. So let's go down here and let's change this from howFull to m.fill. And instead of doing the assignment there, we'll just pass in our level straight to the function. And let's pass in 8 again. And then instead of calling the print down here, like I said earlier, we're returning that value so we can just print it out straight away by wrapping that in a print function. So now I'll save that and let's rerun it. You see we get the same result. So we didn't really fix our problem, but now in this method up here, we can put in a check. First of all, we might want to see if the cup is full. So we could write a method to do that, call it isFull, and take in self again. And what we could simply do is return self.howFull equals self.size. So basically this condition here evaluates to either true or false. So if howFull equals self.size, in other words, if it's full, it'll return true, and if anything else, it'll return false. So down in our next method, we might want to say if not is self.isFull. So we're accessing this method from inside this method, and then we need a colon at the end and indent this. Then we want to run this code. But we also don't want to run this code if the level is more than the size of the cup. So we also want to add a and level less than or equal to self.size. And now we're protected from the user trying to overfill the cup. Although you could argue that filling it up to the brim is too full as well. But for our example, we'll just leave it like this. And then I'm also going to indent this return statement. So I'll save that. And now if we try to run it, you'll see that we got none because instead of returning self.howFull, this return statement didn't get executed because this if statement didn't run. So it just defaulted to the none like all Python functions do if you don't specify a return. So actually I do want to leave that back outside the if statement there. That way we still get the value of it not getting filled up. So if I run it again, you'll see we get the level is still 0 because 8 is too full. We might also want to print a message letting them know that we can't fill it up. We could say else print that would overflow the cup. And then I'll also print please enter a lower number. Let's try that again. And you see we got that would overflow the cup. Please enter a lower number. All right, so we got some cups to work with and we have some basic functionality. But now what is this inheritance I talked about? So we have a general mug class, but what if we want a more specific type of mug? So if you're just in your house ready to drink a cup of coffee, you're just gonna go grab a regular coffee mug. But what if you're about to go out the door to leave somewhere and you really want a cup of coffee? You're gonna grab a travel mug probably. So what if we make a new class called a travel mug? Now this class will share a lot of the same attributes as a regular mug, but it might have some functionality of its own. So let's see what that looks like. Let's go back outside of our mug class and create another class, and let's call it travel mug. Once again, I'm going to uppercase the first letter of each word. That's called camel case, by the way. And now I'm going to use these parentheses. And what these parentheses for are for this thing called inheritance. And now we can inherit from another class. In this case, we're going to inherit from our mug class. And what this is going to do is going to give us access to all the attributes and methods of our mug class. So our mug class is going to be considered the parent class, and travel mug is going to be considered the child class. The other way people reference them is mug will be called the superclass, and travel mug will be called the subclass. Means the same thing as parent-child, just different ways of classifying it. So once again, we'll need our colon at the end. And now I'll just write pass. So as of now, we can create a travel mug and have all the functionality of a mug just with that code. So it's another way of reusing code without having to type all that stuff back out again, just to add a little bit of extra code at the end. that is specific to a travel mug. You can kind of think of it like your parents. You inherit things from your parents, whether it be your hair color, how tall you are, or maybe some health conditions. Well, coding inheritance works in the same way. So now, down here in our main function, I can create a travel mug, which I'll just call TM. And of course, I have to call our travel mug object. And then I'm going to try to call an attribute. So I'm going to say tm.size. And of course, I want to print that out. Now I'm going to save and run this code. And you'll notice I get a trace back. And it says I'm missing one required positional argument size. That's because our mug class requires a size to be taken in. So we also need to take in a size when we call our travel mug. And I'm just going to type in large. Now if I save and run this, well, you'll see that we still get our old code, but our new code prints out that the size is 10, sorry. So you'll see our travel mug got the size attribute for free. I'm going to comment out this code up here for now because we're not interested in that. And we can also see that we can use a method with tm.fill, and we'll fill it by 8, and then we'll print out the result of that to see what the level of our travel mug is. Because remember, it returns how full it is after it gets done filling it. So let's run that again. And you see we get 10 and 8. But now what's the point of this inheritance if we're not going to do any extra stuff with it? So basically this travel mug is just a more specific mug. So what we can do is we can write another init function. Of course, we'll take in self and we'll take in size. And now we also need to run the init function on our parent class. And how you do that in Python 3 is with the super function, which basically just refers to your parent class, which is mug. So basically you can think of it as mug.double_init, open and close parentheses. Now notice here we are calling the init function. We are not defining it for the superclass. It's already defined up here. We're just calling it now. So we don't need to put self in because that'll automatically go in. But we do need to put the size in. And we're going to get the size from the size that gets passed into our travel mug object. So I'll type in size. And we don't need a colon at the end because it doesn't need a block of code because we're not defining the init function. Once again, we're just calling it. So we can just go down to the next line and type any new instance variables we want for our travel mug class to have. So what is different about a travel mug that a regular mug don't have? Well, how about a lid? That's half the reason you take one when you travel. So we could say self.lidStatus, so to see whether the lid is on or off, gets off by default. And I normally make my strings with double quotes. Doesn't matter if you use single or double, it's just recommended that you stick to one or the other. Now I'm going to come down here and I'm going to get rid of this code up to here and I'm going to type tm.lidStatus. So now this is an extra attribute that our regular mug does not have. So let's run that and you see we get the string of off. And we can also create our own extra methods for this class by simply writing new methods. Maybe we want to be able to put the lid on. So put lid on, take in self, and how we can simulate that is just say self.lidStatus gets the string of on. And if we can change it to on, we might want to be able to take it back off again. So we might want to say take lid off, gets self, and once again we'll say self.lidStatus gets off again. And we might want to return a string, or actually we might want to print in this case, took lid off, and here, put lid on, and then I'm just going to copy and paste, change this to put, and change this to off. So now I can come down here in my code and say tm.putLidOn. Now that's automatically printing out that print statement because I'm not returning it, I'm printing it. Remember the difference between a return statement and the actual action a function is doing in Python. If you're foggy on that, you can go watch my functions video. So now our status should be on. So I'm going to copy and paste this down here so we see it again. And let's run that. And you see the lid status was off. We put the lid on and then it changed the status to on. So that's working as we'd like. The other thing you can do with inheritance, instead of adding extra attributes and methods, is you can override the methods of the parent class or the superclass. So for example, filling a travel mug is slightly different than filling a regular mug because, well, what if the lid is on the travel mug? You have to first take the lid off to be able to fill the travel mug. So we might want the fill method for the travel mug class to be a little bit different than for the mug class. You're still filling it up, but the actual method of filling it up is different, depends on the object you're working with. This is also getting into the topic of polymorphism a little bit, but I'm going to leave that for now. Basically, that's a big word that means two different classes having the same method name, but being implemented differently. Now that you're all confused, let's take a look at how this looks. So we're just going to overwrite it by basically just defining it again. Def fill, and we'll take in self, And so now we might want to check if the lid is on or not. So we might say if self.lidStatus equals the string of on, then self.takeLidOff. And we're basically just using the method we defined up here earlier in the class. So note, if we were calling that down here in the code, we'd have to use our instance tm.takeLidOff, but since we're inside the class, we use the self to refer to the instance, because it could be any object we create. After we take the lid off, then we actually want to do the filling, which would basically be the same code we have up in our mug class. So I'll copy that, come down, and outside of the if statement, go ahead and paste that. Now, regardless if you had to take the lid off or not, you're going to have to put the lid back on when you're done. So outside of the if statements, I'm going to say self.putLidOn. I'll save that. Now let's come down and let's come to our travel mug. Let's get rid of some of this code here. Let's say tm.fill, and let's give it a fill level of 8, and we'll print out the result of that, and I'll run the program. Oh, it says fill will take 1 positional argument, but 2 are given. I forgot to take in a level in the fill method. So let's take in a level and let's try running it again. Now let's scroll back down here so you can see the code. Now it says put lid on and 8. So it came into our function and the lid was off by default. So this never ran. So it just filled it up and then it ran the print on function or method. And since we printed out put lid on in that method, it printed out the put on lid down here. And then it returned the self.howFull, which was inherited from our parent class and which is 8. So let's come down here. And let's say the lid was already on. So obviously after we fill it, it makes it on. And since we have a large travel mug, we can fill it 2 more levels. So let's do it again. Let's print tm.fill and let's do 2 more levels. So now it should have to take the lid off to fill it up 2 more levels and then put the lid back on. So let's save that and clear the terminal and rerun it. You see we get put lid on, 8, took lid off, put lid on, 10. Now it might make more sense in the middle here to say print filled the mug. Now let's run that again, and that makes a little more sense. Took lid off, filled the mug, put lid on, 10. Alright, so that's going to do it for an introduction to inheritance. This can be a pretty complex topic. You can get into multiple inheritance and various things like that. But I'm going to leave that for another series, probably an intermediate Python series. So I think as long as you get the basics here, you can keep following along with a lot of my tutorials. So to recap, mug is the parent or superclass, and travel mug is the child or subclass. And sometimes mug is even referred to as a base class. You have to call the super function, and then that is calling the parent class, and then running the parent's init method. And since you're running it, you don't need to call self, but you do need to pass in the parameters it takes in. And you also don't need a colon at the end with a block of code because you're not defining it. With inheritance, we get all the attributes and methods from the parent class, plus we can add our own or override ones that are already there. So I hope that made sense. If you liked it, please give the video a thumbs up. If you haven't yet and enjoy this type of content, please consider subscribing. It really helps the channel out. Also, if you have the means, you can contribute on Patreon, and the link will be in the description below. And as always, I hope you have a great day.